Okay, so let's look at binary shifting. Later we'll look at arithmetic shifting, but right now we are looking at binary shifting, and you can shift left to multiply and you can shift right to divide. So let's look at this binary number here. Now we know that 101 as a binary number is the denary equivalent for that is 5. So 4 plus 1 is 5. Okay. Now if we wanted to multiply this binary number, we shift left. Okay, so we take this binary number and we move everything across to the left one square. And if we look at that, you can see if we move it across one square, you can see that we now have a value not of 5, but if we take 8 plus 2, that is 10. We just fill in the gap with a 0. But what if we want to multiply by more than 2? So we've already said that multiplying by, if we left shift this number by 1, that is multiplying by 2. Okay, but if we go 1, 2, that's multiplying by 4. And if we go 1, 2, 3, that's multiplying by 8. Okay, you can't really multiply by 5 or by 3, for example. So let's test this. If we shift left, multiply, and if we fill in the gaps with 0, so 32 plus 8 is 40. So our original number was 5. 5 times 8 does indeed equal 40. So I want to talk about something called overflow. So if you think about your toaster or your washing machine or microwave, they have limited amounts of memory. And each one of these represents a bit of memory. Okay, so this is a nibble of memory that we are using here. We were using a byte, 8 bits in a byte. We've now shortened that to a nibble, which is 4 bits in a byte. So what happens if we multiply and we left shift and start losing bits off the edge of these 4 bits? Well, that's what overflow is. So we've already said that if we multiply by 2, we are shifting left. That is times 2. Okay, and if we move that, okay, that denary, the binary number, is now equivalent to, it was 5 and is now equivalent to 10. We've already covered that. Okay, now what happens if we move it left again? Okay, now we can't use this number. This number on the far left has gone, it's disappeared because of overflow. There's nowhere for it to be stored because we've only got 1, 2, 3, 4 bits of memory in our program available. So this new number that we have got is not times 4, which would be 20. It is now giving us the number equivalent to a denary of 4. So and that is called overflow, and it's something to be aware of because it's a real thing in a computer system that if you shift left, if you multiply past a certain point, your computer may run out of memory to store that number, that increasingly high number.